Thank you so much, Wendy. It's wonderful to be here and seeing a lot of the students coming in. It's a really nice program, Art of Quantum. I wish when I was a student we had something like that. So really cool, and I hope that maybe today's talk can give you some ideas of my personal journey that may be useful for you. And I welcome any question at the end of the talk. So let me fast forward. Yeah, give you a background of myself. As Wendy mentioned, I did my BA and master's in University of Cambridge, Natural Sciences. So I chose physics as my major. That is a very wonderful time learning physics in this world-class university as well as Cavendish. So I started working in the Cavendish lab since I was in my first year undergrad. And actually, the very first thing that I did was to build dilution refrigerators, which you now may need to build quantum computers. So I did condensed matter physics, experimental as my primary area. And I learned a lot about building instrumentation and went to the machine shop making things by hand. So that was a very interesting type of creativity there. And then I moved on to Harvard University to do applied physics, where I was creating new electronic components. So those are chips developed using plasmonics, the phenomenon you can generate electronic waves in plasmons, a seed of electrons. You can excite waves, and then you can build wave structures, waveguides to guide how your wave moves on your chip, and then use that to make components. So I did a lot of interesting experiments, designed the chips, went to the clean room and made those by hand, and also designed the experiment to test the chips, wrote paper, all of that, the whole research from beginning to the end experience. So working in the clean room was great fun. It was a lot of hard work as well. So wearing the bunny suit and making tiny micro size and millimeter size components. So when I graduated, I went to Intel. That's my first job because it's really related to my PhD thesis. Instead of plasmonic circuits, I was then working on photonic circuits. So similar idea, you can guide photons and light on your chip structure, and you can build infrastructure as a data center where you will use these chips in transceivers where you plug into data servers, and how they communicate between each other is through optical fiber. So you need converting electronic signal to optical signal and converting optical signal back to electronic signal. So you can create lasers and photodiodes on your chip to communicate for communication purposes. So there I learned a lot about scaling from something that you would make in your little research that you may make in the lab by hand, one piece at a time, to something you can scale to a massive amount of chips and wafers where everyone in the world will be using. So that was a very interesting experience, learning how do you build your ideas into industry scale applications. And when I was at Intel, I stumbled upon something really interesting, really fun, which is the open source hardware. So on the right-hand corner, you see this Joule module. Those are tiny computers that you can use to build all kinds of embedded systems. So I actually started becoming a maker. So now we call them makers, where you can use open source hardware to build all kinds of fun projects. For me, it was fashion design, which I will show in a little bit. And then my career went on in a very interesting direction, where because I was working a lot on core technology as well as strategic business planning and building startups. Even when I was at Intel, I was building some internal startups for wearables. And I gained a lot of experiences building corporate incubation. So I had the opportunity to move to Microsoft, and we had a program called the Garage. And I was the manager for the Bay Area Garage program, where is a culture of innovation for the giant company, where you can encourage employees to come up with their grassroots ideas and support them to build these ideas into real products that can benefit more people. So the garage had that function, and I had a lot of fun helping other teams, helping a lot of our employees get their ideas into reality. And also myself, I was working on two technical areas. One is quantum computing, the other is fashion, tech fashion. So during that time, even before joining Intel, I started building a fashion brand called Art by Physicist, which I will show more details about. So now I work at Microsoft quantum computing team. This is something you saw that at the very beginning, I was making the hardware. I was actually measuring the quantum effects of all types of novel materials. And I wasn't really building quantum computers. And even back then, we didn't really have a quantum computing industry. So a lot of the research I did back then was more fundamental. Now we see that this dilution refrigerator being in the news all the time is actually being a very popular feature that a lot of the research teams like to show when they want to talk about building useful quantum hardware. So that's kind of more aligned with my background. But when I was at the garage, I started learning the software side of quantum computing. So I started learning how to code in Q#, which is Microsoft's own quantum language. And I started teaching our colleagues about how quantum computers work. And that kind of contributed me being hired into the quantum computing team at Microsoft to do this full time. If you look at my career trajectory, they seem to have some just two parallel tracks. One is hardcore physics engineering focus, and the other one is more art and fashion and wearables. But they actually have been inspiring each other. For my career and background, I've been experiencing the enlightenment between different fields. And I will show you examples that are connecting science, engineering, design, and art, where when you have these different fields coming together, you can come up with really interesting ideas. I don't think this is the case for this class because we are a class for art of quantum. But we know that generally students are being put into different tracks, and we've been having a siloed education system, but I really don't think that should be the case. If you look at these fields, they're all intellectual fields that are pursuing intellectual value. Science and art, seemingly two polar opposites, they actually are very, very similar. They're doing the cutting edge. Science is discovering things that we never know before. Art, we are pushing the boundary and doing things no one have done before. And those extremes are feeding back and inspiring these practical fields like engineering and design. And right at the interface is where we can communicate with people and touch people and build products and intellectual properties where people would learn and enjoy and need. So I think the intersection is extremely important. And a lot of the problem that we have in industry right now is because of the lack of the merging of the different fields. So when I started working in quantum computing at Microsoft, I paid a lot of attention to what types of people are coming to the field and are interested in learning in quantum. So you can see that there are many different types of skills and background that we really need to scale this industry. Coming up with the idea, as I mentioned, just working in your own lab, building something small and you can write a paper about it is different from having a whole team, industry building this technology and solution that can benefit the entire humanity. So when we do the latter, we really need different types of people. So if you look at quantum, you see there are people who come from maybe math background or physics background. They can create algorithms, but we also need programmers who are able to use these algorithms to make additional applications and development to utilize these algorithms. And then we need researchers to apply these algorithms into solving their other research problems. And we also need educators who are able to communicate all these ideas, and hardware builder and students and early adopters to even start using the new technology. If we don't teach people and people don't understand how this new technology works, then we're never going to get the technology to be adopted. So this is a whole ecosystem and different people that we need in the field. At the same time, we need to encourage people to find the information that they need. Everyone coming to quantum have a different background and different needs. So we can't be providing them information that's one size fit all. And if we look at what we need to learn about quantum computing, we really just need to explain a few physics concepts. I think that the field has a reputation of being very hard, and there's also a lot of hype about quantum computing that is some untouchable high tech that if you don't have a PhD in physics, you're not able to do it. But that is not the case. So we need to teach people the fundamental concepts, but there are also ways we can let people directly use the language and do learn a little bit of math and start writing algorithm and use the hardware. So on different journey, different parts of the journey, different people, they will need different content. So I started building materials to help people understand what they need in quantum computing, what they need to learn, and all through drawings, all through comics. So this is kind of a learning method that I also came up with when I was a student. We were learning physics, but we were also asked to write articles about the scientific idea. So that gave me a training to understand that if we really need to understand a hardcore scientific subject, we actually have to have the skill to describe it in words, make the drawings to explain the words, all the equations, or use the equations to capture, consolidate the drawing or words. So at the overlap interface, that's where we really find the core understanding is. And if we are missing any of these, say when we are writing something or when we're reading our course material, and it seems that we understand it, but then when we actually start making a drawing, and then we would realize actually there's some gap missing about my understanding. So this is a idea, a method that I use for my own personal learning, but then I apply that into teaching. So using these different ways of describing the same thing and using comics to explain had a pretty good effect getting people to start learning quantum. And of course, we now can get hands-on and start coding, which is very convenient and practical. This is what I did when I was working in the garage, just self-organized classes. There's so many people interested in quantum computing. Not everyone has a physics background, and they come from different areas. A lot of them are engineers in other fields, and they need the fundamental ideas to start doing quantum. So that's what I started teaching, self-organized in our garage program, getting our own employees to start exploring this technology. And then I started teaching externally. Last year during the pandemic, everyone was stuck at home, and a lot of people started looking for knowledge online. So I started this class online on Hackaday U, which is a primarily hardware engineer focused platform for open source projects. But people found quantum computing very inspiring. So we got a really big audience following this class. This was all done through my extra time outside my day job. And building comics every Sunday, I was posting a new drawing and then on one specific topic. And then on that day, we're going to discuss that topic. And then next week, we have some new refreshed new topic. So if you're interested in learning the class, here are the links, and Wendy can share this out too. But what I really wanted to show was that by doing a lot of these community engagement, understanding people, and building things that different types of people need really also informed my day job. One of the things that I produced at Microsoft last year was this learning module. This is our official learning material on mslearn.com. So there's a short link, aka.ms/learnqc. This is a set of modules that helps people get hands-on step-by-step from basic understanding to very quickly start coding. So this may be more suitable for people who want to become quantum developers. If they follow step-by-step, they will be able to know how to start using the quantum development kit and write algorithms, and then eventually run onto our Azure quantum cloud hardware. So this was a official product that I released, but it was also through a lot of learning that I gained by doing this creative content for the general public. And of course, that's not enough. As I mentioned, there are so many different types of people needing different types of materials. I then built a website that's on Microsoft's Azure.com Quantum Learn that has an interactive way of providing people customized learning materials. If you go onto the site and you can answer three simple questions, simply gauging how where your interest comes from in quantum and where you are in your skill level, and then it would recommend the materials for you. So this is also something really new that I was pushing the company to do. We didn't have anything like this that is quantum focused. It requires both the creativity and the domain knowledge to really provide different types of audience with the materials they need. So this is another example applying design thinking and artistic way, and then building something that is technical focused and engineering focused. And this also, of course, requires a lot of user research. We did a whole bunch of interviews and study with people from different backgrounds and observing how they interact on the website, and then doing all this website UI UX optimization. So that was super fun work. As a side product, because I was making a comic every single Sunday, and then I got hundreds of pages accumulated, enough for a book. So I did publish this comics on Amazon. That was a very, very nice reward, just seeing your own art and creation put together as a book and made it available for people around the world. When I started, I never thought that I would even publish a book, but then it's all through this interest and passion and teaching people, just making something unique that led to an accumulation of work. So I also plan to do more and maybe expand the comics into general physics. And also I got some media coverage when Forbes was writing about Microsoft. They even found my comics and used it in the article. So that was a really nice surprise. So that shows a little bit of the things that I love that also overlap with my day job, things that overlap with what I am good at and what I can be paid for, and what the world needs. So this is a diagram called Ikigai. It's a concept in Japan, meaning a reason for being. So people may have different types of measurement of success, but isn't success about being happy? You're doing what you love to do, and you have the time you want to spend on your passion and staying healthy mentally and physically. So it's a mixture of different things that we have to juggle in life. And for one who has found Ikigai, usually that's when these four things overlap. And I really, when I was earlier in my career, was really trying to find a good balance between these areas. And I'm very glad that I'm able to do that. Not because people gave me the opportunity to do it, but because I forged my career and I made it work because I pursued what I want to do and make sure that what I do is useful for others. So at some point in the past uh, examples, there was a period of time that I wasn't really in Ikigai. I just felt that, okay, I was making something that the world needs and I can be paid for, and then I was good at it, but it was just not what I love to do. That's when I realized I needed some adjustment. So I hope this diagram will be helpful for you. Take a look at where you are right now. And if there's anything that's missing, you may want to then adjust towards that direction. So have knowing what you're good at and what jobs there are to pay you for it, and knowing what you love may be uh, easy to find because you know yourself. But then how do you then align with what the world needs? They're good guidelines. I've been using those 17 global goals. Maybe I think too much about how important my work is and how important it is for others. When I was very young, I always thought that how do I contribute to the society? And that actually was why I chose physics, because I think physics is the study of nature, and that helps us understand how the universe works and how we build useful things for humanity. And technology is the most direct way to help people. But there are a lot of other options. As I showed earlier, there are different skill sets that we need for anything, and we need a combination of people and people supporting each other uh, to make a good, positive contribution to the society. But if you really want to see exactly how you are contributing to society, the 17 global goals may be helpful. And I can see that what I do on my day job, as well as my passion projects, are targeting several of these global goals, like quality education, industry innovation, infrastructure, responsible consumption and production, and a lot more. So then I'm gonna segue onto my side project. It is not related to quantum, but I think it would hopefully give you some ideas of alternatives. And also, I want to show this similarly a side hobby that is not related to my day job actually is then informing me a lot about the industry. And I'm actually driving a industry scale project that has gained knowledge through pursuing some of my side projects. So I mentioned I built this fashion brand called Art by Physicist. Is a few years of work. I wanted to demonstrate to the world that we don't have to separate science and art, and we can really combine them and inspire from by nature and science and build things for future. That's why I have all these different collections featuring scientific ideas and beautiful nature scenarios, and building open source designs that more people can learn how to make clothing. So before I started this brand, I was actually doing something crazier. So I made a lot of wearables where I literally applied hardware technologies into the clothing. This is a brain signal controlled dress. I was wearing an EEG detector that controls the patterns and colors on the dress through Wi-Fi. And then I applied machine learning in fashion design. This was programmed using a Arduino 101. It has a pattern matching engine and accelerometer and many other components. But I was using these two to detect my gesture and then use the pattern matching engine to memorize my gesture. You basically train the chip for the pattern. Then next time you wave your hand in the right way, you would then call a constellation to show up in the sky. So I also made a lot of similar more functional designs. This is a heart rate monitor that detects my heart rate. You can see on the computer that has all these peaks. That's my heart rate. And then it's controlling the LEDs to blink on the dress. Not everyone wants to show their heart rate to the public for sure. But what I wanted to demonstrate was, why do we have to limit our imagination to sportswear or medical devices when it comes to health monitoring? Why can't we apply similar functionality into everyday wear or beautiful wear we want to have on special occasions with the hardware development? But I think we should push to a direction where we can make beautiful products that also are functional. Right now, we don't have anything like this. So my projects are all open source, where people can find on Hexter.io. That's one of the open source website that I use to upload the schematics, the design, the code. And so if you want to build something similar, you can learn how that's done. I learned so much from the maker community and open source community. And I wanted to contribute back by also making my projects open source. But not everyone is a maker, unfortunately. We always got people who ask where to buy the designs. So it got me thinking, how do we even convert all these crazy ideas into something scalable? I was working on this t-shirt where I was at Intel to design some wearable t-shirt that our volunteers can wear at Maker Faire. And I made these robot design that is attachable, and then a soft circuits on the t-shirt. You can connect the components through flexible electronics and conductive threads. I built everything by hand. But then when we try to make these multiple repeated units to give this to volunteers, we realized that there was no manufacturing capability that can make the soft circuit. The hardware robot was actually easier to make than the soft circuit. So that trigged my curiosity. Why is the industry not there yet that I can make something by hand, but then we didn't have a backend to be able to scale that idea? So that gets back to what I mentioned earlier when I learned how to scale the ideas from the lab to applications. This was then another challenge that really tricked me to dig deeper. That's why I use my brand to discover it. When it comes to manufacturing, you're just battling against limitations. It took me a few years to explore this industry and to find out that the industry of technology, hardware, is very separate from fashion design. the garment manufacturers had no idea how to make electronics, how to embed electronics. And the electronics manufacturers had no idea how to build beautiful fashion. So that's what I specifically wanted to break through, was to change the status quo and to bridge these two industries. So recently we were able to publish a lot of the new designs through our Kickstarter campaign that Wendy has noticed that I'm taking vacation right now, but I'm running a Kickstarter campaign and launch a lot of new products. So we have electronics embedded into clothing, flexible circuits, programmable LED to customize your dresses, and also solar panels, designs, artistic solar panels laminated onto fabrics, and also flexible e-textiles that can be integrated into jackets, and also making open source educational circuit boards. This is an example where, so yeah, we have a successful Kickstarter, which is a great opportunity to learn from the community and see how people are receiving this. This is also a great learning experience for doing something so new that's not people have even heard about this. So this is a side thing that I've been driving. It's my passion area, it's my hobby. So it's nice to see that it's well received, but also getting feedback from people. But that's a whole experience. Doing my projects on the side actually gave me a really deep insight into a much bigger industry. In this case, fashion industry, where I actually learned about the dark side, about the ugly side about fashion. It could be all about the beautiful things that we design and people like it because they like the art and the beauty. And I think that's what should be driving the fashion industry. However, what's really happening is that this is a really big industry and it's got $3 trillion value and contributes to 2.3% of global GDP, but it's also the largest polluting industry, one of the largest polluters in the world. The industry is dominated by mass production, mostly for bigger brands, fast fashion, and then every year 30% of clothes are actually never sold. They are sent to landfills and get burned, and 10 million tons of clothing are sent away and becoming trash. It produces 90 million tons of textile waste, and 10% of carbon footprint comes from the fashion industry. This was heartbroken for me because I was doing things as a hobby. I had passion, I had fun, and people liked it. And then this discovery just removed all the beautiful aspects about the fashion industry. So why should it be the case? The industry is this problem is really well known by the industry for years and years. And every year we're talking about sustainability and we have to solve the problem, but then we don't see real solution. Until COVID hit last year, it really reduced the volume production for fashion. And most of the production were then mobilized to producing PPEs. And we see the drive then became demand driven, what is really needed to be produced. So is not good for the industry. COVID definitely hurt the industry, but it's actually good for the environment. From the environmental standpoint, it's kind of a wake up for many businesses. But then we also see that the economy gradually going back, the same problems are coming back and the industry may be falling back to the old habits. And then I also learned that at the same time is very painful for anyone involved in the fashion industry. There's so many pain points. Designers, as a designer myself, I explore the whole process of how to create, to produce. Because of this mass production model is not encouraging and supporting independent designers to create small volume and interesting designs. It's very difficult for manufacturers to build anything really creative. So if we go outside, most of the clothing are done by mass production and similar designs, but then each style could take months to make, and it costs so much money upfront for a creative designer to build anything new. Just not even embedding technology, just normal clothing can be that much. And then manufacturing is dominated by mass production. It doesn't support independent designers, and then the traditional industry doesn't have the tools or mindset to change the way of making to a on-demand production model. And most of the factories are still in developing countries where they're not, workers are not in very good conditions still. And consumers, we all shop, we all buy clothes, and we know that we have to fit our bodies into the size and cookie cutter made mass produced goods, rather than the clothing is designed for our sizes and body shapes. And that becomes a very big pain point where we never find the clothing that's suitable for us. And there's a huge accumulation of inventory by brands. As I mentioned, 30% is never sold. So I come from a semiconductor manufacturing and IT background. I couldn't help but wondering, why can't we borrow something from the technology sector to apply to fashion manufacturing? Can we help the fashion industry using some of the ways that we do in electronics manufacturing? So for my own brand, because it's small, I can do things made to order. I can do simulations of the clothing before they're even made. I can demonstrate those. If I can digitally capture the design, I can build from 2D to 3D, and then also make one-off designs for people. So I figured it out for my own brand. I could just stop there and say, okay, that's what we're gonna do, small volume and made to order. But then on the industry scale, at a larger scale, the whole industry needs a solution like that. For the entire industry, we need to allow people to do mass customization. Those are two very conflicting ideas. You either do mass production or you do small customization. But what people need really is to be able to satisfy their look and their fit. And we need technologies to do that. And only when we do that, to do made to order, we can then reduce waste and pollution problem caused by the industry. So we need a complete ecosystem that allows designers to bring their vision to reality. And it's all captured using digitized formatting and modularization and pattern. And then we should be letting people to choose based on what they want to buy. And we already have a computer vision to allow people to maybe search for images and recommend new and similar designs. But we can also not produce those things. We can let people upload images and then figure out how to make it, find the files that's needed to make that clothes piece, and then produce for the consumer. And of course, we can also modify the designs to fit people's body and have people do virtual try-on before they're even made. And then the manufacturer has to be democratized. It has to be local and distributed. And a lot of the steps can also be automated if we can capture the design or digitally. So these are all the concepts that we've already been using in making electronics and chips and digital software is not quite being applied in the fashion industry right now. So that's a project that I'm driving at Microsoft to build a whole set of solutions and connect them to complete this ecosystem where we can support creative designs do made to order and support local manufacturers and support consumers to get the things that they want and need. And then when we do that, we can cut down the waste and pollution from the industry. And before doing that, we can continue to contribute through donations. And that's what my brand does personally. But I think a lot other brands should do that. So especially for my brand, you saw that all the inspirations come from nature and science, and that's where I want to contribute back by donating to STEAM and environmental protection. So that's also the mission for my brand. And I think we should only be creating products and goods when people need it and shouldn't have a negative impact on the planet. So as I mentioned, I think a lot of the problems in the industry are caused by silos. But if you look at the big picture, everything is connected and they're logically supporting each other. We are learning science and engineering, and we build machines. There's a lot of the hardware and software from the ground up, from chip to PCB to control, writing the code, algorithms, to building machines that can do automation, mostly to more efficiently support consumer goods and infrastructure production. So when the material need is satisfied, we can create art and culture. And why do we need art and culture? Because those are the things that generate happiness, that can push us move forward in a positive way. So being a maker and doing my side projects really led me to pursue a journey of turning creativity into productivity and applying things that I learned. Even is my passion project, it helps with what I do every day. And it also let me realize the interconnections between many different fields. And when applying methodologies across the field, they can positively enhance each other. Sciences are the study of nature, which itself is art. Technologies are based on science, which empower people to create better art. That is my talk. Thank you for listening.